In this lesson, I'm going to go over some basic concepts in geometry that you want to be familiar with. So the first thing we're going to talk about is a line. What is a line? Now, many of you may think of a line as just something that looks like that. But in geometry, a line would have two arrows. And so it extends in opposite directions forever. Now, let's put some points on this line. So we can call this line line AB. We could also call it line BC, and we could also call it line AC. So there's many ways in which we can name this particular line. Now, what about a ray? How would you describe a ray? A ray has a point and it extends forever in the other direction. So it has a point and an arrow. So let's put some other points on this ray. Let's call this A, B, C. So we can name this ray AC, or we can name it ray, not BC, but AC. I mean AB. The reason why we can't name it ray BC is because the first point has to start at the initial point or the starting point of the ray. So we need to use point A as our starting point. Now the next one you need to be familiar with is something called a segment. A segment has a beginning and it has an end. So let's say this is point A and point B. So we can describe it as segment AB with no arrows on it, or we could say this is segment BA. So that's a segment. Now let's move on to angles. There's 4 different angles that you need to be familiar with. So the first one is an acute angle. Acute angles have an angle measure of anywhere between 0 and 90, but it's less than 90. That's what you want to take from this. And so we can call this angle ABC. And if you notice, an angle is formed by the union of two rays. So here we have ray BA and ray BC. And so this forms at the vertex, creating an angle. The next angle is the right angle. And a right angle has an angle measure of 90 degrees. The next one you need to be familiar with is something called an obtuse angle. So the obtuse angle has an angle that's greater than 90 but less than 180. And finally, you need to be familiar with the straight angle. The straight angle has a measure of 180 degrees. So that's a straight angle. It looks basically like a line. Now let's move on to the midpoint. What is a midpoint? Well, if you look at the word, it sounds like the point in the middle. And you wouldn't be incorrect by saying that. So let's say if we have a segment, we'll call it segment AC. And let's say B is the midpoint. So what does that mean? That means that B is right in the middle of segment AC. It also means that segment AB and BC are congruent. So if you put these marks, it shows that this segment is equal to that segment. And the way you would write that is as follows. So you'd say segment AB is congruent to segment BC. And so if that's true, that means that B is the midpoint of segment AC. Thus, B bisects segment AC into two equal parts. Now, another term you need to be familiar with is something called, what just happened here? Something called a segment bisector. So let's say if we have a ray that passes through the midpoint. And let's say this is R. So ray RB is considered a segment bisector because it bisects the segment into two congruent parts. So we can see that AB and BC are congruent to each other. Next up in our list of things to discuss is the angle bisector. So what is an angle bisector? An angle bisector is a ray that bisects an angle into two equal parts. So let's say we have, let's call this angle ABC, and we have a ray that emanates from point B, and let's call this ray BD. So ray BD is an angle bisector if it bisects angle ABC into two equal parts. So let's say that angle ABC is 60 degrees. By the way, when you name an angle, the vertex of the angle has to be in the middle. So you can call it angle ABC, or you can call it angle CBA. So B has to be in the middle. So if ray BD is an angle bisector, that means that angle ABD has to be 30 and angle DBC has to be 30. Now let's move on to parallel lines. So what do you know about parallel lines? What are some properties of parallel lines? Parallel lines never intersect. So let's call this line A and line B. Parallel lines also have the same slope. So let's say the slope of line A is a half. The slope of line B will also be a half. And the way you can describe that these two lines are parallel, the geometry symbol for it looks like this. So you say A is parallel to B. So you would use two lines to indicate that A is parallel to B. Now let's talk about perpendicular lines. What are perpendicular lines? And how are they different from parallel lines? As we said before, parallel lines do not intersect each other. But perpendicular lines, they do intersect each other. In fact, they do so at right angles. So let's call this line A and line B. So they're going to meet at a 90-degree angle. Now, let's say that the slope of line B is positive 2 over 5. What is the slope of line A, given that it's perpendicular to line B? To find the slope of a perpendicular line, first, you need to flip the fraction and change the sign from positive to negative. So the slopes are negative reciprocals of each other. And the symbol for it goes as follows. So we could say line A is perpendicular to line B. So that's the geometric symbol that correlates to perpendicular lines. The next term that you need to know in geometry is complementary angles. So what are complementary angles? Complementary angles are angles that add up to 90 degrees. So let's say if we have a right triangle, and let's call this triangle ABC. So the symbol for that is as follows. So this is triangle ABC. And let's say that angle A is 40 degrees and angle C has a measure of 50 degrees. In this case, we could say that angle A and angle C are complementary because their angle measures add up to 90 degrees. And so that's the basic idea behind complementary angles. So the measure of angle A plus the measure of angle C is equal to 90.